Okay, good afternoon, all colleagues, all students. Today is the second day of the DesignFest 2023, and in the afternoon session, we are with Nicolas Ziesel. First of all, again, Nicolas, we would like to thank you for accepting our invitation, first of all. Before Nicolas' presentation, I'm going to introduce Nicolas Ziesel and their company, Cause Architects. Nicolas Ziesel is a part-time lecturer at Architecture and Landscape School in Lille and organizes a Learning by Doing studio at Abiyan School of Architecture. He's a vice president of AFEX, an association dedicated to helping French architects working abroad. He's an associate member of the SV Camp, a nonprofit running transitory urbanism sites with a high social impact, and he coordinates a community-supported agriculture group, always cooks too spicy and dances to undanceable music. The company Cause Architects was founded in 1999 by Christophe Ohayun and Nicolas Ziesel after graduating from ENSA Paris Belleville. The office is located in Paris and focuses on timber architecture from forest to home. Current projects range from big with part of Athletes Village for the 2024 Paris Olympic Games to small with an experimental house on Martinique Island. The 25 people strong team adopted a 4-day work week a few years ago and is currently launching a small manufacturing workshop. Today, Nicolas will give a lecture with the topic, We Don't Care About Architecture Anyway. In this presentation, he's going to explain their philosophy, and he explains this philosophy as we care about plants and animals, we care about designing decent, affordable, and resilient living conditions for all in a changing world. So the stage is yours, Nicolas. We are going to listen to your presentation first, and after the presentation, we are going to accept the questions, if you agree with that. So whenever you are ready, you can start. Okay. Thank you very much again. Mm-hmm.
Thank you very much, Enal. So it's always a bit a challenge to do these presentations. Talking about our philosophy, I mean, 20 years after starting to work, I don't know if we really have a philosophy. We're always working in progress. And in a way, these sort of presentations also help us to mark up a moment in our thoughts, in our path. So really, thank you very much for the invitation. And I hope it's going to be, you're going to like it. So the title is a bit provocative. We don't care about architecture anyway. To be honest, I borrowed it from a movie about punk Japanese musicians. It was called We Don't Care About Music Anyway, but it sort of quite fits because architecture, as I learned it in a way, which was very much about making big buildings, traditional, and with a very much long focus on architecture as something autonomous from society and from history and from living conditions, I think does not really exist anymore. And we are always changing and trying to find a way to still be able to help with the skills that we have learned, with the skills that we have developed, and also to adapt to very changing circumstances. So yeah, we are, I think he announced about everything about the office. So we work mainly, of course, in France, but also Wood has brought us to go a bit to a lot of places for festivals, workshops, and also, as I will explain, also in a bit on the tropical levels of Earth, which are those who have a very high requirements regarding climate change. So we don't care about architecture, but still we do architecture, but we care about plants. This is almost one of our first projects. And really the whole purpose of the project was to keep, it was refitting an old building in Paris that had to be demolished because it wasn't in very good conditions. But yet there was this tree that was living there. And well, we made everything to keep the tree, which was not a very easy task in a very small plot, and to help it develop and become really the first inhabitant of the place, the one that will welcome everybody. And so here it is today. It is really at the middle of the composition. It is your friend. You pass under him when you go to your apartment. You see him when you climb into the staircase, which is just in the middle. And it really gives shade in the summer. And this sort of the sound of the wind in the leaves. It is really somebody, yes, that lives with all the people who are there. And you also see it from the street. It belongs to everybody. We care about animals. We have never made a project for animals, but we are always very sensitive to what is happening on the ground. What can we see? So these are, maybe it's because we have a dog in the office. He's on the right. But we are always fascinated when we find these little animals or bigger animals that exist inside our projects, inside our architecture. The one on the left was a small lizard in a project that we were building last summer in Italy. And of course, we care about people because we've done a lot of social housing when we started. And we care about trying to give as much freedom and quality to the people and as much quality of life possible. On the left side, you can see the balcony. You will see the project after. On the project we did in Paris, the whole idea was that there was a sort of extra room that people could really implement like they wanted. It was not required. It was giving them something that was outdoor, but that could also become indoor if they wanted to change things. And we are very much always attentive to having a sort of relationship between the inside and the outside, the presence of light day. And at the right is really something that is one of our greatest pleasure when we were able once in this very dense city of Paris to bring daylight into the toilets of social housing, because this is something that changes completely the perception that people will have of the living space and the experience of the everyday life there. So here is the project I was talking about, and you can see that everybody has sort of arranged his exterior space the way he wanted. There is also a very interesting sociological study that has been made about how people invested what was happening inside, and they have always very surprising ways of taking over the plans that we make. One of the things that makes us most proud as architects with this project was one of the people who lived there. And really, it was exactly, we were with him, next to him, seeing the project like this. And he said, you are the architects. I must tell you, I find this building really, really ugly. But when I am in my home, when I am in my apartment, it is the best place I have ever lived in. And I think this is probably the best compliment that an architect can receive. Being focused a bit on social housing, we are also, of course, and because we traveled a bit around the world, and for architects, traveling is quite a necessity to really be confronted to the living conditions that exist elsewhere. Either they be much superior or more dire than the ones that you live in. And of course, the issue of the slums is something that we are very much aware of. That is very difficult to cope with, knowing that you already have, you see, about 1 billion people living in slums, and you can see that they are concentrated in this tropical area I was talking about. A lot of countries in gray, there is no data. That doesn't mean there is no slums. There are slums in France. There are slums in the US. But there is something about if if you don't put the data, then it doesn't exist. But there are really terrible living conditions happening really next door from us, and we are sometimes trying to help on that too. We also know that in the next 25 or so years, population is going to change, and you can see that living conditions in the world are going to shift a bit radically. There are places where cities are going to shrink because population gets down, and here the main issue will be how do you retrofit what exists already, stop building. You have cities that are a bit stable, and here it's also about more or less about retrofitting, about building a little bit, and then you have these growing cities, and you can see that it is mainly going to happen on the African continent. The thing is that this is also going to happen in the climate change. Climate change, of course, you know about it, and I guess some lecturers also give you some figures, because we are a bit interested in this perspective of 2050, growing population in Africa, which has already a huge slum problem. And also, it is a place that is going to be more or less the most impacted with Southeast Asia by increase of temperatures, and mostly the increase of something that is called wet bulb, which basically at some point your body cannot cope anymore with the heat. And this is going to happen in places where the population is going to grow the most. And it's already happening because if you look at this was Monday yesterday, maps of wet bulb in Africa and Southeast Asia, everything that is red is already temperatures that are largely above a comfort level. It means that when you live in these conditions, you are going to live longer than most people. It's going to be harder to work. And also, if you have some money, you are probably going to spend a lot of money on air conditioning, which is going to, in a way, worsen the problem and accelerate climate change. Growing population is something, when you think about that, is completely crazy. We need to make, as you see, some billion of square meters every year, which means that basically till 2050, we are building one Paris city every week, which is completely a dimension that is very difficult to cope, to understand, and to realize what it means. And a good part of it is going to be informal, at least at the beginning. And from studies, we know that, for instance, in French Guiana, informal settlements, the cost is 42 euros per square meters. So one of the big questions that we are confronted in the very near future, even in Europe and of course in a lot of countries, is how can we lower the cost of building so that for probably a bit more than 42 euros, but something that people can afford, something that governments can afford, something that NGOs can afford, people will be able to be housed in conditions that allow them to cope with climate change. We're also interested a lot in people, since this is my small part on theory, well, at least on inspirations. There is a great text by a philosopher thinker called Ivan Illich. You probably heard about him. It's an address he made to the RIBA, the British Institute of Architecture, called Dwelling. And in it, there is a sentence that has really struck us, and that we are, in a way, since we read it like maybe 15 years ago or maybe more, we're still struggling to work with it. It's the sentence that architects can do nothing but build, and the vernacular dwellers generate the axiom of the spaces they inhabit. And this is a bit what I was thinking. It's about this contradiction that we have. By building, we are imposing axioms of spaces to people who have other ways to live, so sometimes predictable, sometimes totally unpredictable, and sometimes changing. So how do we, at the same time, answer this growing need of new, comfortable, climate change compatible housing with the possibility for people to be the actors of their own space? We probably also got interested into these topics because we, almost from the start of the office, we have started working with wood. We first started, and let's be honest, we started with wood because of its sensitive qualities. I mean, it is something that really addresses all the five senses, even taste. Because if you have ever tried to eat something with a spoon made of concrete, good luck. But it's really something that brings material that brings this. It ages. It has this superb sound, the touch, the smell. It's really something, and it relates us to also the natural world and the passing time. Working with wood has made us also very interested in forests. And being interested in forests, you're also interested in what the people who live in the forest. And in a way, a lot of the people that are called so-called primer people or whatever that still live, for instance, in the Amazonia, and had to have been studied by anthropologists. And you have two books that I really recommend you. One is called How Forests Think, and the other one is Beyond Nature and Culture. They are pretty heavy books, but they quite change the perspective that you have on the, let's say, progress, the going further of civilization, and they sort of also reflect in a bit of different way of thinking the history of humanity and the path that we can choose or not choose to do from now until 2050, which is, as you know, going to be probably a big tipping, symbolic, but also very real tipping point for all living beings on Earth. We were quite pleased, and maybe because we are always, maybe because we don't have a very strong theory, we are always very keen on what is happening, and also how a sort of consensus is being built around these issues. And there is one element that is going to be, in fact, I'm going to use this thing for the rest of my presentation, made by one of the United Nations body, which is the panel on biodiversity and ecological services, which is a bit brother of the one that works on climate change, but it works on nature. And they have tried to make what they call the methodological assessment on the diverse values and valuation of nature, to take into account this incredible diversity of the relationship we have to the natural world, which is not only, of course, economical, but has also a lot of other different aspects. And these aspects, we were very sensible to this report, to this assessment, because in a way, intuitively, we had crossed them in all the moments that we had been working around building in wood, building for the people, building with nature. It's also a very hot topic, this question of the value on nature. I was in two conferences not so long ago. One which was in Gabon, in Africa, One Forest Summit, and the super hot topic was carbon offsets, which means putting an economic value on the preservation of the forest versus the interests of indigenous communities that live inside the forest, that make their living with it, that sometimes transform it, and that had they made it. The people representing them made this very strong statement: "Help us to save you." This is really something. We have this relationship now, wherever we are, to a lot of other people, other plants, other ecosystems that we are really relying on an everyday basis, even if they are not next to us. What is also interesting is that the price of a carbon offset is $10 to $30 when big companies invest in these tropical forests that are so critical for climate change. But it rises to $100 when they are investing in forests in Europe, because they see, of course, a much more easier return on value, return on investment in a forest that is nearer to the factories, nearer to them, that probably they could one day just cut to do something. And the other one was, of course, was a conference in the United States on mass timber. And once again, the question was, mass timber is probably something good for the planet for reasons that I will maybe talk about a bit later. But it costs more than building with lousy materials. So how can we compensate? And so there is all this issue about can a part of it, the carbon that is inside the wood that you have in construction, can it be valued for the sustainable goals of companies? But let's go back a bit to this report, to this assessment. The first relationship that we have to nature is living as. This means that you feel part of nature, that you have an emotional, even a spiritual in a way, level of connection to nature. And it is something that you see, of course, when you study people who are actually living more or less isolated in nature, for instance, of people living in the forest, but that you can also see in other conditions. You have here two trees. The one in Gabon, the story goes that they were making the road going straight and they had to cut this tree. But when the workers were getting closer to the tree, they didn't feel well. The machines started not working. They felt sick. So at some point, they just said, okay, the tree doesn't agree to be cut. He is telling us this, he is really, the spirit of the tree is making us sick. So let's just make the road around the tree. That's possibly a good attitude. And very interestingly, I found exactly the same sort of attitude in the center of this huge metropolis of Tokyo. And the story is about the same. There was a construction that was going to be made. There was this tree that was on the border of the plot, and they cut it. And a few days after, the tree started sprouting again, but very vigorously. And the Japanese, who have a very strong relationship to nature, said, oh, there must be a spirit in this tree, or something. The life of this tree does not want to go away. We have disturbed it. And so the first thing that they did was to bring a priest, a Shinto priest, to make a ceremony to apologize to the tree, then to put this small rope around. And also they decided to push a bit backward the building to leave space to the tree. So this is something that in anthropology you would call a very animist attitude, that you give conscious intentions to a living being that is not human. But for me, it's a question: can we maybe shift? Or maybe we should shift from being urbanists to urbanimists, to having this conscious of everything living that is not us, that lives in the cities, in the places that we live in. The second aspect that we have is living with. Living with means that you are completely part of the place that you live, that your lifestyle is completely accustomed to a certain type of ecosystem. We made a competition last year in French Guyana to make very low cost social housing, trying to compete with these 42 euros per square meters, which is basically impossible. While we were there, there was a very strange situation. On the left, this is new social housing for people who are living in almost slum conditions. And just really nearby, you just they see each other. On the right is a place of people who have actually access to a housing in this building, but they do not want to leave the place that they live, the shack that they live, that you can see here, which is not, of course, a very neither sophisticated, neither very comfortable. So, of course, the question is, what is the issue? The issue is very simple. These people, the people who are there, one generation, or maybe even in this generation, they are people who were living in the forest, and they came to the cities because they have this impression that probably living in the cities is going to bring more wealth. It is also because it's difficult to live in the forest, because it cannot allow too many people to be there. But since they have ways of living that they cannot do in these social housing buildings, one of them is cooking outside. It is something that is very cultural. They do not cook everything outside, but for instance, if you go hunting and these people who are living in a city or still go hunting. They come back with alligators, snakes, things like that from the forest. You never cook it inside the house. You always cook it outside in these sort of small cooking areas. And then they have something else, which is a washi, which is a sort of ritual of cleaning yourself when you have been angry, when you suspect somebody of having bad intentions for you. Same thing. This is something that you cannot do inside a regular social housing because you need to be outdoor and because there is a certain ceremonial involved in it. And so we made the project really trying to take into account as much as possible all these and a lot of other ways of living of these people to develop this sort of prototype of a very low cost housing. It's almost like a upfitted slum in a way, where you can live outdoor, where you can do the washi, where you can do the cooking, and where you have also a certain relationship to the plants that are around the house. A second project that of living with will be one that we are doing in Martinique, and I just understood that yesterday Philippe Madec has been talking to you about Le Prêcheur, and we are involved in fact with a project where Madec is chief urbanist. Le Prêcheur, it's a place that is pretty beautiful, as you can see on the left picture by the sea, but it's also a very dangerous place. It is beneath the volcano. They have all the natural risks that you can imagine, except snow avalanche. But they are subject to earthquakes. They are subject to the eruption of the volcano, to cyclones, to tsunami, etc., etc. It's yet people belong there because it is a place where they have always belonged. It is a place that is very fertile, where it is very easy to live by growing food on the slopes of the volcano. The current situation is that, and of course, the people are there right now. The volcano is in a sort of orange alert level. So there is really a question, two issues. One, it is to take people away from the sea in case of tsunami, and the other one is to think about how the people will be evacuated in case the volcano starts an eruption. But then there is also, of course, even if it is temporary, also taking into account the way that they live. And they have a very special and interesting relationship to the landscape, to the way that plants are set to protect the house, that there is a sort of transition between the common shared place to the private, to the place where you grow your food, and to the forest. And so we made this proposal. The proposal was made in a way was not made with architecture. It was mostly made with how do our plants how our plants settled on the site to accommodate the living of people. And then, of course, people change. If you may be a small couple when you start. Second time you're going to have a child, and you have going to maybe the grandparents are going to move in, so the garage becomes a small studio, and you are also maybe going to develop an economic activity in your house, so maybe you need a place to do it and to sell. And really, it was the whole project was about setting a sort of guideline so that to make this possible. And for instance, you can see on the picture, but I also have them right here. We made these sort of small elements of modules that are really bedroom or typical spaces to allow people to, in a way, determine by themselves, by assembling them in a way or another, what is the house that they want to live in, what is the disposition of the places, so that they have this sort of freedom of making the new house that they will move in. Because this is also a bit experimental, because we are also working with local materials, trying to work with local wood, with vegetables. Vegetables. I'm going to talk about this with earth, trying to make these new paths that will allow people to connect between home and forest. There is also a sort of prototyping phase of making scale 1 tests to sort of be able to validate this. And this is, of course, because the conditions are super hard. You have these cyclones that can really take away a house. So we built our own small wind tunnel. This is the first test. It wasn't so efficient, and we started trying to find a constructive system that could resist earthquakes. And so we started with a Japanese system that, as you can see, is able to withstand an earthquake of Kobe level. But we also wanted, to work with other materials, with natural materials. And so once again, we took advantage of working with a test center in France that has done a lot of tests on seismic tables, on systems that can be used in countries like Martinique, using wood and earth. And this sort of test gives you an idea of what are the weak points of this type of constructions that use a different type of materials. And we are going basically to work with this wood system that you can see on the bottom left, an infilling that will not be in bricks, because you can see that there is a big issue of bricks falling. That can be a bit risky when the earthquake really shakes, but more with what you see in the middle, which is a sort of composite made of residues of sugarcane that is used to make rum and lime. And so right now the project is going to be going a prototype, but a real scale 1 prototype that is going to be inhabited by somebody. And this is just a small drawing of what it is going to look like at this stage. There are, of course, a lot of other things on natural ventilation, on the rainwater use, on the solar energy for the lighting, etc. And of course, a plan, an organization that takes into account the way of living of the people with this outdoor gallery that connects all the living spaces. And of course, speaking of scale 1, we also wanted to see if this story that we were telling ourselves, that we are going to find a way that we make a house and it can be easily taken away if the earthquake or the volcanic eruption starts, that you can move to some other place. Is it so real? And we took advantage of this super luck of making a smaller pavilion in Rome at this beautiful garden to make a test for ourselves of let's build it, let's try to see how it works. And also at the same time, we're not doing it just for a purely technical reason. It was also a summer festival, and also trying to bring how does it feel to live in these places? How will it feel to live in these sort of outdoor galleries where you can have this hamac? Obviously, it works well. How can we bring food that grows on the construction, that brings a sort of garden to have tomatoes, vine, and things like that. So it was not just a technical test, it was also a living test. The fourth aspect of this assessment is living in. It's just taking advantage of being in a place where there is nature. This is also because, of course, since we build in wood and we have this sort of a passion for trees, every time we have enough space, we want to plant trees. And so we had this wild proposal for a competition that we lost, that was about redoing all the area around the Eiffel Tower. And basically our proposal was you have a garden where trees are more treated like objects than individuals, where they are in bad conditions, where they are unhealthy, where they are always sick. It's time now to take the people out of this area, to put them where they want to be, which is in front of the Eiffel Tower, and to let all the wooden area become a forest, to regenerate a forest, to regenerate a living ground, which will be able to host animals, going from worms to birds, to cats, even to foxes and things like that. This is something that we think is really has a huge potential in a city. And it's also, of course, there is a pleasure of being in the forest. There is the fact that when you are crossing a place that has become a forest, you know that you lower the temperature in summer times, which is something that is going to be very crucial next years. Having a strong forest is also something that is resistant to strong winds. And this is one of the windy parts of Paris. So it's also something that prevents storms from taking away roofs and things like that. And of course, because it's going to be cooler, it's also going to have a huge effect on the urban heat island effect around. And we had this calculation, I don't remember the figures, trying to figure out how many air conditioners just planting double the trees that existed was going to prevent in all the neighboring area. Of course, this is something that we did a bit intuitively, but again, there are a lot of people involved in this, and we sort of love this 330-300 rule for urban forest. That is really something very simple, but it is probably going to be and should be implemented in more cities. It's quite a shame that there are more cars than trees in most cities. Living in means also that you are able to act on what is happening around. And these are two projects that we obviously lost because we sort of didn't do what was expected. On the first one on the left, it was a small square in a city. And basically, we proposed that half of the budget was not to make urban design. It was to make just to pay people who are going to be able to bring all the people living in the area to take care of the outdoor space, to start planting, and to sort of make a hub for taking care of the natural space that was around, or overdeveloped the natural spaces around. On the right, it was a proposal for a new urban setting with 2,000 home units. And here the whole idea was to bring back food, bring back cultivation inside the city, because this had been a place where a lot of that used to be fields. So the thing was, first we make the fields, we provide food for the people, and then we build, and we build no more than what we are able to feed in this area. And of course, we lost because at the time, it was something like 10 years ago, it was pretty hard for an elected local government to admit that they had that they were going to build too much, that they had to slow down, that they had to sort of take into account different things. And of course, the last thing, which is the one which is for the actual, what we could call the economic value, is living from nature. Of course, we obviously we live from the trees just because of this wonderful equation of photosynthesis, which all the plants do, transforming carbon dioxide plus water plus the energy of sun into glucose and oxygen, which means that basically trees and plants are just with the sun making Coca-Cola so that they are able to grow, to have energy. And they are releasing oxygen, which is also what makes you very happy when you are in a forest or amidst nature, a natural setting. But of course, living from, what can we build? Can we build with wood? Right now, this is the situation. Maybe you know this graphic on the human-made mass Earth on Earth. And you realize that basically there is more mass of concrete right now, more mass of anthropogenic mass than of biomass, of all the living beings. In this, the building materials, you have concrete. Concrete is a nightmare. You know that it's the third CO2 emitting country in the world after the United States and China. Is there a chance that we make green concrete in a very near future? Well, chance is very slim because it will require to have a large-scale carbon capture and storage, which basically in the time scale that we have until, let's say, 2030, 2050 is probably not going to happen. Of course, there are a lot of studies to make a greener concrete with biogenic materials, using hemp instead of steel rods and things like that. But it seems that concrete is not going to help us a lot. You have bricks, very strangely, as you can see, bricks, which is a really universal building material, is not so much in volume, in mass. It's quite little, it's 8%. We have also a bit of issues with bricks. Bricks is making holes. When you make holes in the land, you are taking off soil that is a living soil. The first 50 centimeters, 1 meter of soil are very full of living beings that capture carbon. And also in a lot of countries, anyway, in all conditions, brick requires energy. So a brick is also emitting carbon. And I have this example in Malawi, which is a very small and poor, one of the poorest African countries, where the tradition is making building with bricks. So basically, there are two issues. People make holes to make the bricks and to take the earth to make the bricks. These holes, because it's a country where it rains a lot, become mosquito places when they're in the raining season. And to sort of stabilize and make the bricks a bit stronger, they are burnt in these beautiful pyramids. It looks like an old ruin, but in fact, it's the bricks for a home. And so there is a lot of trees being cut to do that, which is, of course, an issue. The country has lost almost 90% of its forest cover in 1 century. But also these bricks, in a way, are not so resistant. Malawi has just been hit, maybe you heard about it, by a huge storm. And a lot of constructions have been ruined, like the one that you can see. Lots of people died, and a lot of reconstruction is going to be to happen. But obviously, there is the necessity to find another way of building. And then there is metal. Of course, I'm not going to talk about it because it's even worse than concrete in terms of carbon dioxide emissions. But as you can see, finally, there's less metal than one would think. And then you have the 2%, which is wood, glass, and plastic. When we say wood, glass, and plastic, of course, wood is part of plants. And on the other side, you can see that the biomass is 82% plants. So this means that this capacity of biomass of renewing itself is probably one of the good ways to build today, if we are able, of course, to manage well the forest, to be super efficient the way we use wood, and also to introduce other plants than wood, than timber in construction. And of course, there is a long tradition. I've talked about what we are doing with the sugar cane, but you can see also here in Guyana with the palm trees that are used for cover. And a lot of people are working on how to make sort of composites between fibers that are not wood and biochemistry to make sort of synthetic wood out of plants. Yet, if you look at what we have right now, this is for Europe. Of course, is it possible, for instance, that everything that is going to be built in Europe for the next 20, 30 years be made of wood? So this is a study that showed that what are the possibilities? Well, a great possibility, of course, is timber. And then the second one that you can see is straw. Straw that is about the equivalent of timber in terms of capacity of building. So it's quite encouraging that these sort of studies are available, because they sort of open our imagination to with what can we build. And of course, when you build with straw or when you build with hemp, but as you can see, it's not going to be so useful with cork. It opens up a lot of new possibilities in terms of aesthetics, in terms of structure, and in terms of experience for the people who live inside. Coming back to trees, of course, thinking of not only trees, but also all plants is super important, because this shows you the map of where are the 3,000 billion trees that will be here in 2050. but also what is the tree cover evolution from now to then. And you can see that there is a lot of deforestation that is going on in the tropics. So we have this paradox that where it is the most needed to construct fastly with sustainable materials, it is the place where these sustainable materials are also the most endangered. Hence, the idea that possibly developing new types of materials with other plants could be a good approach, and limiting, of course, the number of trees that we use. Even so, there are also studies that have tried at a global level to see, is it possible to build everything till 2050 or even 100 in this case, to make that all new buildings are made in trees? And is it still possible to have forests that capture CO2? Is it still possible to have land to fill a growing population? And so there is this study very recent from the Potsdam Institute for Climate Impact Research that I'm still trying to understand, I must admit. It's also this that at some point I'm reading more this type of researches than architectural books or architectural magazines, because it's pretty important to understand what are these figures. After there's the slogan saying that we can build everything in timber, what are the impacts? How will it change the way that we work? How can we implement it in our everyday work also? Of course, wood, I said, has this huge advantage of capturing CO2. There's always this story that 1 square cube of concrete emits 1 ton of CO2, whereas 1 square cube of wood captures 1 ton of CO2. And we've been pushing a bit the limits of what you can do with wood with this project of housing. It's not social. This is for people who buy apartments. In Strasbourg, it is, so you have 12 levels. And you have 11 levels of structure that is only made of mass timber. Strasbourg is in a very complicated climate. It's very cold in the winter, very hot and damp in the summer. And it's also one of the places in France with the maximum seismicity. So it was quite a challenge to have such a structure that would be able at the time to bring comfort, but also to withstand a major earthquake if it happened. So just a few pictures of the project. We've also always this idea of thinking about the people and turning places that are usually hidden, like bicycle places where you make the bicycles, places where you get your mail, where you dump the garbage. They are not hidden inside the building. They are here really at the front. They are something that welcome you, that brings this a change of scale between the street that is going to be planted and the more intimate spaces that you go to going to your home. So this is a picture of the construction when we had finished the highest parts in wood, and you can see that it's made with this system of mass wood panels, but also mixed with other type of construction. Such a project, architecture is of course important because it's we take a lot of decisions, but then there is a huge amount of negotiation, of talking with different stakeholders that have a very different interests, between the city that wanted to promote wood construction to boost the local economy, between fire engineers who were very cautious because they were frightened of what would happen if there is a fire in such a building, between, of course, the developer who is very worried about the cost of the building. And this, the fact that we have so many discussions with so many different levels of people is also something that has changed a lot the way that we work. We are here not to make our project. We are here in a way to help a collective project exist between the discussion with all these people. And of course, it extends to ordinary citizens, because it's a city where there was a lot of local participation and consultation, and of course to the people who will live there afterwards. Yeah, I went a bit fast. Sorry. Okay, it's this. So just to show you how everything is done. So as you can see, this is all manufactured, which means also that the people who operate it have better working conditions. They just manipulate elements that have been made off-site, and they just have to put them very simply. Still, it's not everybody that can do that. It requires skill, knowledge of the material. The three guys that you see here are super qualified, but they know the material, they know the skills, and they are able to make also this building go up very fast. The second thing was the seismic earthquake issue. At some point, these new engineered wood systems, they rely a lot on metal pieces that stick the wood together. And all the seismicity of the capacity of the building to resist earthquakes is taken into account in all the facades, because in a wood construction, contrary to a concrete construction, it's not so important that the structure moves. And it's in a way better that it has so that you control the movement rather than you try to block the movement. And that's what the engineers, led the engineers to privilege that the facade was going to move. The only problem we have is that it's impossible, even with the best computers and software that you can find, it's absolutely impossible to simulate what is going to be the deformation of the metal piece that connects the wall to the floor in the case of an earthquake, because it happens in very random directions, in very random moments. It's impossible to simulate. So we were sort of stuck at this point, that the project was not going to be able to be done just because of this. And this is where skills are important, because it's the timber builders who came with this solution, which you see is called muraillère, which is a very traditional way of joining a floor and a wall that has been done since the Middle Ages in Europe anyway. And basically, it's very simple. It's just this piece of wood that is connected both to the wall, both to the floor. But since it is something that goes all the way, and it is not something that is just at a point, it's much easier and much more conventional to calculate the deformations, and hence to know if the building is earthquake-proof or not. Of course, then there is fire. Once we have solved that, there was the issue of fire. And we had a whole one-scale mock-up of 2-3 levels that was made, set into a very strong fire to see how the structure was going to resist, how the facades were going to resist, and if the people were going to be able to be taken out of the project in case of fire. As you can see, at this time, we had wood facades. Obviously, not a good idea in our case of a very high building, because the wood facades led to a faster burning point to the upper levels than a metal facade that we had put, even if, of course, it had a better impact, carbon impact. Then there was the issue that we had to protect all the wood structure inside, because simply if the fire starts, the structure is going to preheat itself. And then when the fire arrives, it starts burning faster. And this has a major risk, because it's going to, people are not going to have enough time maybe to get out. So we sort of tried to devise systems where you could still see the wood and at the same time protect the structure. But in the end, these systems were a bit too expensive, and we ended up basically you are in a wood building, but you almost do not see any wood inside, which is also a bit of pity, because you lack this sense of the material, this contact with the material. And one of the main issues, of course, was that we were promoting the idea that we are building in wood, because wood has this capacity of carbon storage, and that we wanted to implement this. So we started making calculations. In 2017, this is what it showed, that it's the figure on the bottom right, that compared to a reference building that would have been made in concrete, we were capturing 149% more carbon. We had a better score, much better score. But things have changed, because of course, this issue of carbon impact, embodied carbon impact, is becoming more and more important in construction. And right now, since 2 years now in France, we have another regulation that takes into account embodied carbon. It's the 4 columns on the right that is called IC Construction. What is interesting is that it has been made in steps, so that the more we go near to 2030, 2050, the more the expectations are going to be high. And you can see that we go from 671 to 421 in a span of almost less than 10 years. And so we made this decision also to do reverse engineering and see, okay, if this building was going to be built today, what would happen? And so you realize that for all the other indicators that are important, that you have to attain to comply with the regulations, it's okay. You see that with the carbon storage, it's okay until the last step, where it is obviously a little bit above. This is a sort of figure that shows you that, of course, you embodied carbon. You have both the carbon that is avoided. This is the one with the wood. The red part is the one that is embodied but that emits. This is when we use concrete, metal, etc. And then you have operational carbon, which is the one that is emitted by the use of the building. This is something that we did with a very easy tool. You can use it and try on your own projects very easily. Of course, the issue is that it is made with United States data, so it might prove a bit different to what the results you would have in Europe, but still it gives you quite a good idea of the direction that you are taking. And you can see that, well, in the end, in 2050, in this calculation, embodied and operational carbon are going to be much higher than the avoided emissions. So we are not yet on the zero carbon path. But when you look a bit closer, what are the issues that we have in the embodied carbon? You can see that the primary structure with the orange is quite okay, but you can see that there are 2 elements that are quite huge. One, revêtement intérieur, means everything the interior finishes, and élément de doublage is the insulation. If you concentrate, and then you have, of course, the envelope with the facades. When you look at the facades, the big disaster here was that the economic choice made, because wood was more expensive, obviously more expensive than regular construction, was that we have plastic blindings on the windows. And this is the one that rises, you see, to 40. So obviously, if you are able to stop using this, to find another way to do it, you are going to have a better score. And in France now, for this regulation, we have this huge database on the carbon impact of building materials. But you have different types of levels of data. You have data that is provided by the government, which is a sort of the level 0. You have the data that is provided by syndicates of builders, like the providers of windows. They make a sort of estimation of windows that applies to all them. And then you have individual manufacturers who will find their own elements. Obviously, you would expect the data from the individual manufacturers to be better. Well, not always. And here you can see, for instance, what happens with the interior finishes. We have, because we are heating and cooling the building with water, hot water in winter to raise the temperature in a concrete slab, and cool water in the summer to bring down the temperature. Well, the concrete slab has this huge environmental impact. But that's because we chose to do it with the data we had at the time of the building, which is 2018. Now, in 2019, there is this collective figure that goes, and woof, we go from 47 to 10. Great. But then the guys who had made the actual product that we used, they had individual data. They really made the data on their specific product in 2021. And here up, we rise from 10 to 25. So there is a lot of research, a lot of work still to be done to know exactly what is the impact of what we build on this carbon, embodied carbon aspect. Then I told you a bit, I was talking also a bit about this issue of taking good care of the forest. Because when you use wood and probably any natural material, any plant material, it's not just a material that you buy in a store. It's a material that has a story that goes from being planted, being maybe farmed, to being cut down, harvested, to being transformed, maybe 1, 2, or 3 transformations. At each transformation, there are great issues of loss that, because it is a natural material that has stored carbon, carbon is going to go back to the atmosphere. So here is a sawing mill in Gabon, in the center of Africa. And you can see the logs that have been taken out of the forest. But today, this is a country where no one builds in wood, except maybe very poor people in the slums. So no one builds in wood. So all the wood is made to go abroad. And because to sell it abroad, it must have very strict aspect, no knots, no defaults, and things like that. There is a lot of wood that cannot be sent abroad, and that is basically burned because we are in the middle of the forest. There is no market, there is nobody. And we worked with the people in the forest industry and to have a sort of estimate of what is happening. And the estimate is that every day they burn one house with, as you can see, material that looks like it could be possible to use it. When you go a bit further, it's even worse than that, because when they cut a tree in the forest, 70% of the tree stays in the forest or becomes burned. It's all the branches, it's all the upper parts of the tree, all the lower parts of the tree. So there is a huge waste, and only 30% of the tree goes to the first transformation. And of this 30%, only 50% gets into actual building or furniture materials. So basically, when you cut a tree in the tropical forest, you have only 15% of the tree that is actually going to be used. You have 50% that is going to be burned, and 70%, we don't really know what's going to happen to it. But maybe that instead of cutting another tree, if we could reuse this 70%, transforming into building materials, maybe this is the sort of hypothesis I was talking about, of making these new bio-engineered fiber building materials. Maybe this is an issue that could be really helpful. And this story of waste is something that is absolutely infinite. I showed you this small pavilion we are doing in Rome. We had done in Rome, and after that, we had a commission to do a sort of food court in a building, and there was this issue about the furniture. We are going to have like maybe 1,000 people every day sitting. So of course, it's possible to buy seats, okay? But then we said, okay, with what we have learned of using digital tools to make to cut and to make very simple things, maybe we can build ourselves this furniture, and maybe we can find wood that is not going to be used, waste wood, to do it. And this is where we found this absolutely improbable thing, just to show you that when you look around, there is resources everywhere. You're going to use art transport cases. You know, the things that the museums, they put a Picasso inside to ship it to an exhibition on the other side of the planet and then bring it back. But when they bring it back, they have this box. They pay so that the box gets burned, which is completely absurd regarding the quality of the wood that is involved. It is the same wood that you saw being burned in the forest. The good ones have been shipped to Europe to build these crates. And so we sort of decided to make our own small lab. This was I was telling at the beginning, our small lab, buying this digital cut machine, learning how to become a craftsman, to be able ourselves to make these 1,000 shares for this new place that is going to be around Paris and opening at the end of the year. Thank you.